Hello everyone, welcome to my YouTube channel CNC for TDM. Today in this video we are going to discuss machining parameters. Machining parameter while using CAM software. Suppose these are some standard parameters of pocket milling. Pocket. So when you are doing pocket milling on a CAM software, there are three types of parameters. Tool parameter, one is tool parameter, and other is pocket parameter, and third is roughing finishing parameter. These three type of parameter we have to define. So let us discuss one by one. First is tool parameters. What is tool parameter? First thing is in tool parameter, diameter of the tool. What is the diameter of the tool? This is here. Tool number given here. Tool number 1, 2, 3, 4, whatever. This is head number. And this is diaoffset. Diaoffset means G41 or G42. Length offset, height offset. If there are many tools, then you have to define one standard tool, and then with the help of G43 command, you have to define length offset also. And here it is given. This is tool is flat. Flat tool is there. Tool diameter is given 5.0 mm. This is tool diameter. And then it is corner radius. So if corner radius is 0, that means tool is flat. Corner radius is 0 means shape of the tool is like this. It is flat, completely flat. And if it is a ball nose type tool like this, ball nose, full radius is there, then if diameter of the tool is 5, then corner radius will be 2.5, half of the dia. If this radius is 2.5, then it is a ball nose, and if some corner radius is 1 mm or 0.5, something like that, small radius is there, then it becomes a bull nose cutter like that. So if you see here, this is in diagram. If you see, this is flat nose, flat cutter like this, and this is ball nose, full radius is there. This is bull nose, some corner radius is there here, and some portion is flat. So this is called bull nose, and it may also be a chamfer tool like this. So this is geometry of the tool basically. So you have to define this, and in these parameters, then is spindle speed, that means RPM, how much is the RPM of the tool, revolution per minute, and this is coolant on off. So, and here it is program number, maybe 1000, 2000, whatever is the program number. This is sequence start. When you make a program, then sequence may start from 100, sequence increment 2, that means 100, 102, 104 like this, just like N1, N2, N3, a sequence number. So this way we define tool parameters. So in tool parameter, these are the things: geometry, shape of the tool, dia of the tool, and tool numbers, etc. Dia offset, length offset, and RPM of the tool, and this sequence number, etc. And one thing is there, this is feed rate, plunge rate, and retract rate. Plunge rate, when it is taking entry into the material, it is plunging into the material, that is plunge rate. It should be very less as compared to feed rate. Feed rate is cutting feed basically. When tool is cutting in X and Y axis, so that is feed rate, and plunge rate is when it is taking entry in Z axis. And retract, it may be high because it is retracting in Z axis upward direction. So this is retract rate. So these are tool parameters. Then is pocket parameter. Next is pocket parameter. If you see here, These are the pocket parameters. This is your pocket. Say this, you have to machine this type of pocket, and this is given here, top of stock 0. This is means Z0. When you are taking top surface 0, this is your Z0, and this is depth. This one is depth. The depth is, it will be in minus only. It may be minus 10, minus 20, whatever. This depth you have to define here, and it may be absolute or incremental, this depth. And then is feed plane. Feed plane means this is your feed plane. Feed plane is a tool will come into the actual feed. It will plunge in the material. Plunge rate it will take from this point. Plunge feed will be there. Very slow Z entry. So that is your feed plane, like this. Feed plane is 10 mm. So, and then this retract plane is 50 mm. 50 mm. From 50 up to 10, it will move in rapid mode, and then it will be in plunge mode, plunge rate. It will take plunge rate. Here it is in retract rate. Okay. So these are the parameters, some parameter, retract rate, retract plane, feed plane, and then top of the stock and depth. These are all defined here. And then is machining direction. Machining direction, climb over conventional. That means whether it is up milling or down milling. You have to define whether you are going to machine in up milling or down milling. And then compensation, tip compensation is there. And one thing is stock to leave in XY stock to leave. If you are doing this roughing parameters are there, then you have to keep some stock in X and Y axis. And Z stock to leave in Z axis, if you want to keep some finishing allowance, that you may define here. How much is the stock you have to remove in Z axis in finishing only. So these are some parameter. This is here depth cuts. If there are many number of depth, you can define some depth cuts. If it is suppose 10 mm and you want to take 5 cuts, then depth cut you are going to define how much is the depth cuts. So these are pocketing parameters. In the pocket, what are the parameters? What is plunge rate, feed rate, and everything. So this way you can define here. Next is roughing finishing parameters. In roughing finishing parameter here, if you see here, these are roughing finishing parameters. One is, this is a roughing style. It may be zigzag shape. Cutter may be in zigzag like this. It may cut in zigzag shape also. And it is constant overlap spiral like this. Spiral cutting, constant spiral cutting. It is parallel spiral cutting like this. And it is parallel spiral and clean corner. Every time it is cleaning corners, parallel spiral is there. And this is morph spiral, and this is high speed spiral like this. And this is one way only, not zigzag, but it is one way machining. Then it retract in Z axis, again it take the cut. So you have to, according to your machining, according to your job, you have to define all these things. So these are machining methods, how you have to machine it, the pocket. And then step over is given here, 75%. Step over means this overlap, this distance is there, the step over distance here. Every cut you have to take at this step over distance is given 3.75 mm. Suppose cutter is 5 mm dia, and step over is 75%, then distance will be 75% of 5, it will come 3.75. So then 3.75 is the distance in each steps like this. So, and this is roughing angle. If roughing angle 0, then it will be in like this horizontal. roughing angle may be 45 also, then it will come in 45 degree like that. So this is roughing angle, finishing angle, and then spiral inside to outside. If you click this, then spiral will be inside to outside. From inside it will come to outside. Otherwise it will be outside to inside like this. So these are the things. And then finishing is there, finish pass is there. In finish pass spacing is given here 0.25. Cutter compensation is given here G42 or G41, that compensation is there. And one more thing is there here, helix entry and lead in lead out. These two things, what is helix entry and what is lead in lead out, this I am going to explain here with a sketch. So this is our helix entry. When it is plunging into the job, it takes helix entry like this, so that it may not damage your job. So entry will be very, very slow. If it is helix entry, it will take entry into the material with very slow jet feed like this. So this is helix entry. And one thing is lead in lead out. This is lead in lead out. When you are machining a contour, a profile, then you have to take entry from the outside. Lead in means some length of the line is there here, and then radius is there. So it will take entry like this, and it will machine this and come out in the same way like this. So this is lead in and lead out. So this way you can, these are given here: clearance height, rapid height, feed height. These are things are given here. So this is lead in lead out. Okay. So these are the parameter, machining parameter, while you are doing it on CAM software, and it may be any CAM software. So these are standard parameters which you have to define for pocket milling. I think now it may be clear to you. And please, thank you for watching. Please like, share and subscribe. See you soon in next video. Okay.